Okay, so let's take a look at Unified Threat Management, and we'll get into finding out what this is all about right here. So essentially, we are going to look at the challenges of branch offices. We're going to look at the features of Unified Threat Management, and look at how each of these features addresses the challenges of a branch office. And we'll take a look at the devices, hardware devices on which UTM is available, and look at the features of it and the various licenses that are required to run it. So on a branch office, some of the issues that we have: spam, phishing, we've got malware, viruses, and so on. There also is the issue of unapproved website access and unapproved content. So UTM addresses all of these things. So it looks at how we can do something about spam, deals with viruses, generally viruses, trojans, spyware, all known as malware. Looks at how we can prevent unapproved website access and unapproved content. Now those last two are really kind of more like organisational policy type things. So we'll get into those. The spam and phishing again is more of a security thing. So these can be security issues, but also can just be a nuisance thing as well. And viruses and everything that comes under this topic of malware is definitely a security issue, security threat. So UTM deals with these things. Now, one of the things just first up that I want to look at with this is most of these things are all to do with application layer stuff. So viruses, their application layers, stuff that's coming through email, spam, phishing, it's all application layer stuff. A lot of this website content is in that category as well, or can be in that category as well. So the thing about a gateway or a router is that a router is not generally in the business of looking at application layer stuff at all. It's in the business of looking at layer 3, layer 4, dealing with those layers. So it's not generally in the business of looking at application layer stuff. That application layer stuff is end devices. So when it arrives on your PC or it arrives at a server, that's when the application layer content becomes relevant at that point. So for our gateway to examine application layer content, it's going to have to open up that layer, which it wouldn't normally open. So it's going to have to go in, open up the application layer, inspect the contents of those packets, and then forward those on again. Okay, so it's quite a lot of additional work that routers and gateways are not normally in the business of doing. All right, end devices deal with application layers. Intermediate devices generally don't. So this type of activity here, I will just sort of point out, this type of activity, this UTM activity, consumes quite a lot of processing power when you start implementing these things. Okay, so it's just one of the things to be aware of, is that you think, well, I've got this SRX device, it's doing my zones, my policies for me, it's taking care of my VPNs, I've got my IDP stuff running on there, it's taking care of all that fantastic security stuff. Well, let's chuck this on as well and make it do all of that. One thing to bear in mind is, okay, there is a limit to just how much stuff you can chuck on one device before you overload it. And what happens if you do overload it? Well, if you do overload it, then basically nothing works. So it just loses the ability to process connectivity. In other words, you lose internet access, you lose network connectivity because your gateway can become overloaded. So there's a bit of planning involved here. If you're thinking, yeah, I want to have on my branch device, I want to have security policies, which of course you will, that's absolutely essential. You're going to have zones, you're going to have policies, that's the whole point of it. I want to have a VPN between my branch office and my other offices with That's probably essential as well. You probably want to have your intrusion detection prevention running because that's kind of a security threat, so you want to get that taken care of. You're going to want to run your screen options on there because that's a security threat as well, so pretty much you're going to want to have those things happening. Then you think, well, I want to take care of my viruses as well, right there at the gateway. Yeah, it's a good idea, but then you have to start thinking about what type of device do I need to handle all the stuff that I want it to do. And so you do have to kind of bear that in mind. And at that point, it's probably good to start talking to your Juniper product experts that can say, well, if you're going to want all of that, then you're going to have this device. Okay, so it's probably going to be a device that has a reasonable amount of processing power, just to handle all of that. Okay, so let's just get into looking at these different topics. So here we are: anti-spam, antivirus, web filtering, content filtering. Okay, so how does this work? Here's looking at our flow module again, and all these UTM features come under the services section right here. So we're really going in, at this point, we're going in and opening up our packets, looking at the application layer stuff, and then passing those packets on. So UTM traffic processing, we have a application proxy. So comes in to an interface. We're going to examine a security policy. Okay, is it allowed? We have a TCP proxy where it emulates a server. So what we have to do here, we kind of have to emulate an end device. We have to kind of emulate a host to open up the application layer and inspect what's happening in it. As I said, this is not stuff that gateways and routers usually get involved in. So we want this to happen. We've got to sort of emulate what an end device might do. Open up the TCP proxy, open up the application proxy, and then we can look at our web filtering, content filtering, anti-spam, and antivirus. All happens up there because we're now dealing in the application layer. So let's take a look at an overview of each of these, and then we'll go in and look at the detail of each of these and how to set it up and configure it. So we'll probably be this afternoon before we get into the detail of all these things. See how far we get this morning. So anti-spam, antivirus, content filtering, and web filtering. Anti-spam will tag or block unwanted email. Antivirus will drop virus-infected files. I mean, that's something you would really ideally want that to happen at the gateway. It would be fantastic if all viruses could be stopped right there and they don't get into your organization. Content filtering blocks specified content, and web filtering controls website access. So content filtering is, you might say, well, we're going to block this type of content. So you don't want people looking at certain stuff on the internet at your branch office. Okay, so there would just be stuff that you just don't want in your organization. It becomes a problem if that type of content gets in. It becomes a problem for a whole range of things. Imagine that you're working in a school environment, for example. There's stuff you actually don't want in that environment, in a school environment. There's children there. Absolutely, you don't want stuff. That is probably the same stuff you don't want in any work environment, quite honestly. So it's just stuff that you want to, that can cause big problems for an organisation if that kind of content gets into the organisation. So there is stuff that you definitely want to block out. Okay, so let's look at our design. As I mentioned, there is a CPU and memory performance issue when you start getting into these parts of functionality. Some features require additional CPU processing. In fact, they probably really all do. I've played around with this on some lower end devices and totally taken them out. that if I enable everything on our current gateway, it will become non-operational. It will just stop processing traffic. That is the end. Okay, you will not get an internet connection if I just enable all this stuff, even on our current gateway. So you can overload devices, definitely can. Configuration components, we've got custom objects. So we're going to look at these things and how they're used in the UTM profiles. Feature profiles looks at the operation of a specific feature, and we've got policies. So what we do is we actually take a policy that we've already got in place, a security policy, and what we're going to do is we're going to add this UTM feature profile into traffic that is being evaluated by a particular policy. So what happens is, just like we did with IDP, where it's the policy that invokes the UTM function, just like the policy invoked the IDP function. So it actually gets added into the permit. The traffic that is permitted by the policy will then go into this next phase of evaluation, and it will then be evaluated by our UTM process to see if it gets through that process. So kind of it's the policy that directs the traffic into this particular process. Okay, so we have some objects. So we start off with objects, things that we're interested in evaluating in our profile. We create this this feature profile, and we add it into a policy that directs traffic into it. So the UTM policy flows, you have a matching policy with a permit function, and we then go and look at a particular protocol that we want to examine, and then that protocol is passed through into our UTM functionality. So we're not going to examine each and every protocol. We might, for example, we'll be examining HTTP protocol, when we're looking at our web filtering and content filtering. We're looking at our mail protocols for anti-spam, and potentially antivirus as well, and looking at probably HTTP or even FTP for our antivirus as well. Okay, so we can take a look at the session status here. We've got UTM session info, maximum sessions allowed, total allocated sessions, and total free sessions. You can set up like a limit on how many UTM sessions you're going to allow to be created, just to try and help to stop overloading your device. You can see that the server status there is running on this particular case. Hardware support. We need the high memory version. High memory version means that it's just got 2 gig of RAM instead of 1. So anything with 2 gig of RAM can run this, and can potentially run UTM. Show chassis hardware will tell you what you've got. The H at the end of the model name tells you that it is the high memory version. It doesn't need to be PoE, this one just is, but it doesn't need to have PoE on it. This needs to have the H, not the PoE. Power over Ethernet doesn't need that. So you can have an extra module here, this CSA. It's a specific chip in the device which is designed for processing what's called express antivirus. So it's a content processing chip. It's an extra chip on the device. You'll note here that the SRX 100s don't have it. In actual fact, to be honest with you, you would be hard pressed to make any of this work on the SRX 100. To be quite honest with you. Once you've got everything else that's on there, like your zone policies, your IDP, your screen options set up on it, and if you've got a VPN, you're going to try and throw that on. It's just not going to happen, guys. Okay, so You probably forget about your SRX. In actual fact, Juniper doesn't make those low-end devices anymore. Come out of production. You can still get them second hand, but it's just not going to work on those little devices. You can use chassis cluster support enabled for anti-spam, express and full file-based antivirus scanning. It's a couple of different antivirus scanning modes, content filtering and web filtering. So that is available on a cluster. Okay, and licensing. So you do have to get a license if you want to run these extra features. There is you need a license if you want to run Express antivirus or full file-based antivirus. There is Sophos antivirus available as well. Anti-spam, need a license for. Content filtering, you don't need a license for it. Surf control web filtering, yes. Web sense web filtering is no, and enhanced web filtering is yes, and local list web filtering is no. So most of the things, well, the things you need a virus for, generally what these things do is they reference an external database. So a license really just gives you access to that database. So these antiviruses, for example, using Sophos antivirus, you're going to be referencing that database of signatures, of antivirus signatures, which you'll have to download and update onto your device on a regular basis. So you kind of get access to that signature database. Same goes for some of these other databases, Express antivirus, full file-based antivirus. There is a signature database that you're going to be accessing. When it comes down to things like enhanced web filtering, again, what that does is it's looking at content filtering. So you've got a database of websites, and the websites are categorized by their content. And it will actually look at certain content, and it can block certain content out of a website based on its rating or its information that is contained within an online database that is referenced in relation to that website. Things you don't need licenses for is like a local list, where you just make a list of websites, and a thing called web sense web filtering, which again is fairly basic in its operation, and content filtering is also fairly basic in the way that works. This is just an example here of licensing for, let's go back to the previous slide, for the Express antivirus, full file-based antivirus. Juniper used Kaspersky antivirus signatures for that. So you are in actual fact implementing Kaspersky antivirus on your gateway. I found it pretty good myself as an antivirus engine, as an antivirus software. So you're actually implementing that. You're accessing the Kaspersky virus signatures, which you'll download onto your device and update on a regular basis, and you'll essentially be using that engine to evaluate traffic that's coming through on your device. So if you do a show system license, you'll see what licenses you've got set up on. This one's got antivirus, anti-spam, and surf control. Alright, so that's just a bit of an overview of UTM and what it does. So the goal, of course, is to look at blocking and viruses, blocking spam, and controlling access to certain web content. And that's all being handled by our gateway device. It's quite a good place for that to happen. I guess one of the points there, which is really important, is the fact that this takes a lot of processing, and you can easily overload the device when you start throwing all that onto it. In actual fact, just on that point, there are things that happen on your network that can overload your processing. Generally, if you have problems on your network, you can very easily overload your gateway. You guys were aware we had a network outage last week, and that's exactly what happened. We had some stuff happening on our network. We actually had a switch that died. It started to malfunction in the process, and it just started to throw a lot of spanning tree traffic down onto our network, and kept initiating a spanning tree transition. So it kept initiating a topology change. And one of the things about spanning tree is while it's in transition, no traffic can be passed by a switchboard while it's in transition state. And if it's constantly in transition state, you get a transition request every second, which is exactly what was happening, then goodbye gateway, goodbye switch. Okay, no traffic is going anywhere as long as that's happening. So apparently that's not an uncommon thing when you get a switch that starts to die and malfunction on the network. So just coming back to, again, this issue of overloading devices, that was a malfunction which overloaded a device, but you can load up your gateway with so much stuff that you can overload it with all the stuff you're putting on it, and basically have the same effect. You just won't pass any traffic. Okay, so 4 supported UTM features. So we did look at those 4, which were spam, viruses, and then there's malware viruses, all that. We've got content and web filtering. So you just look at sites. And then there's content. What's the actual content? So with content, you might open up a web page and part of it won't display because that part of it sort of matches against content which is being blocked. We have a lab on that we are going to do. Okay, so let's just let's get into our next topic. Have enough time? We have plenty of time actually. All good. So let's just dive out of that and let's get into anti-spam. See if I can make this behave. And looks like hopefully it will behave. And it goes over there. Okay. A bit more Greek. Okay, so let's look at anti-spam and see how that one works. So we're going to look at the methods, terminology, describe how UTM examines traffic for spam, they configure and verify and monitor anti-spam operation. Right from the start, what I've got to tell you here is that this only works if your mail server is sitting behind your firewall. This will work quite well where, just say you've got Microsoft Exchange in your organization, that's your mail server. If you've got that sitting behind your firewall, which is kind of where it will be anyway, it would be behind your firewall. It works very well. If you're using your ISP's mail server, then this is not going to work. So we'll find out why shortly. So we're going to look at how it works, methods, terminology, and configure and verify. So here we are, unwanted email messages. Different subjects. We're going to look at a subject. It'll look at different warnings. It basically scans your emails for content, and it picks up the content and then rates it as spam. Now, of course, you can get. I mean, if you are using your ISP's mail server, there are anti-spam filters that your ISP will have that will do this for you as well. But if you've got your mail server behind your firewall, then this can be set up on your firewall. Okay, so we can use an external database server to identify spam email senders. These are known as block lists, email block lists, and these are actually quite common as well. They can be useful or they can be a nuisance at the same time. Block lists are managed by various organizations. Microsoft run a block list, Google run one. There are a list of these block lists. If your mail server ends up on a block list, what that means is that other people won't be able to get your mail. Now, the problem with that is you don't necessarily have to be spamming people to end up on a block list. If you send enough emails to the wrong email addresses, you can end up on a block list. For example, if you send emails, just so you misspelled someone's email address, and you send an email to that address, if you do that too often, you can end up on a block list. Okay? Let's just say, for example, as students, you gave us your email address, but we typed it in wrong, or we couldn't quite read it on the application form and put it in wrong, and we sent out emails to everybody on a regular basis, and yours was wrong, we could end up on a block list just because we had a few wrong email addresses and we sent out people on a regular basis. We can end up on a block list. So a block list can be good, it can also be a nuisance. But typically, if you are a spammer, like you do regularly send out spam, you'll end up on one of these block lists. But the other way you can end up on a block list is if your mail server got hacked and somebody used it to start spamming, then you also end up on a block list. Okay. So there's a few different ways you can end up on these block lists, but basically, if you are on a block list, what will happen is the Juniper device can go and examine these block lists, and it can prevent mail that's coming from those source IP addresses. Because when the mail arrives, in the header of the mail, you've got the IP address of the server that sent the mail. And of course, it'll just examine that IP address and can just block it out. That mail won't go anywhere. So, a thing to be aware of as well is that if you suddenly find that a particular organisation can't receive your mail, and you're thinking, how come they can't but other people can? It just comes back to what sort of anti-spam mechanism are they using, and it could be a bit of a flag for you to realise that probably you are on a block list somewhere, and that's probably a good time to start looking at why am I on a block list and how do I get myself off of it. Often you can contact the organisation and they will be able to tell you which block list you appeared on, because they're whatever anti-spam mechanism they're using will actually have a record of the fact that what block list you're on, and then you can go in and contact the people who manage that list and request to get yourself removed. Alright, so a bit of a process sometimes. If you do happen to find that your organisation appears on one of these block lists. But these are, Juniper will use these block lists, other organisations will use these block lists to filter out spam. So basically your server ends up on a block list, and then devices like this will stop passing through mail from your server into the organisation. Okay, can be a problem. We found that problem with Juniper. So we communicate with Juniper a fair bit, and we ended up on a block list somehow. And the only organisation that we could not send mail to was Juniper. Any organisation in the world that we couldn't send mail to was any email address ending in juniper.net, because their global system, their global mail system said, oh, you guys must have appeared on a block list at some point, and therefore you're not getting through. So yeah, it can be quite vicious in the way it works. But it definitely blocks spam, definitely does that. So Usually server block list requirements, any spam license must be installed on the device. Internet connectivity to the SBL server must exist. Got to have DNS set up on your device, which you would. And any spam profile must have the SBL server enabled. Server, that's your server block list. So list of mail servers or IP addresses along this block list. Okay. Now, if you do find that you're managing one of these devices and an organisation that you need to receive mail from rings you up and says, "Hey, why can't you guys receive any of our mail?" Then what you can do is you can go into your device and you can simply put their server onto your whitelist. Okay, well then suddenly you'll be able to receive their mail. Right? So what you're saying is that even though an address may appear on a server block list, if you whitelist that address, you will be able to kind of override the fact that it's on the server block list, and you will be able to receive the mail. Alternatively, you can blacklist as well. So regardless of whether it's on a server block list or not, if it's on your blacklist, all mail from that server will be blocked. Sometimes that's a really useful thing to do as well. Okay, so the whitelist is all the sources you want the device to accept, and blacklist is all the sources you want the device to reject. Very simply. Order of checking, we look at the whitelist, look at the blacklist, and we look at the SBL server. So if it's on the whitelist, all good, don't look any further. On the blacklist, all bad, don't look any further, you're blocked. And if you're not on either of those lists, always go and check the SBL server, see if you're on there. Okay, traffic examination. Now look at this slide here, and you will see that we have got user 1 sending email to the mail server. So the traffic between mail servers is SMTP, and the client will use IMAP or POP3, but usually IMAP nowadays, to receive mail. Okay, so one of the things about this particular functionality is that it only inspects SMTP traffic. So it does not inspect IMAP traffic here. So if your server is behind your firewall, okay, so in other words, SMTP traffic is coming through your firewall to your mail server, then that will be inspected. But if your server is out in the cloud somewhere, the IMAP traffic will not be inspected. Okay. Alright, so identifying spam, it's just compared against an anti-spam list for a pattern match. So the SBL server has criteria for listing an IP address as spam. We've already covered all of that. So once spam is identified, it's either blocked or tagged. So blocked obviously doesn't get anywhere. Tagged just tags the subject as spam. You put a spam tag onto the subject. And how do we configure and verify and spam? We configure our whitelist, configure our blacklist if you need to. You will, because of the way that these SBL servers operate, it's quite likely that you may need a whitelist just to allow organisations that really do need to communicate with you. I mean, it's not that strange for somebody's mail server to get hacked every now and then. It's not that strange. And it's amazing how long it takes to get off that block list. It might take 6 months to get off block lists. You can request to get off block lists. It can take quite a long time for this problem to totally go away. Depending what block list you're talking about and what server we're talking about, what SLB server we're talking about, but it can take quite a long time. So you may need to go on whitelist. an organisation. You may also want to blacklist certain addresses that are just problematic to your organisation. But the main point is that it gives you control of what mail gets into your organisation. You're going to create a policy to reference the anti-spam profile, and we're going to assign the policy to a security policy. So here we are. Here we're under security UTM. Right down under, that's our allow list, that's our whitelist, that's reject list, that's our blacklist. Under feature profile, anti-spam, okay, we're referencing our whitelist and our blacklist, so we're actually referencing the name of them there. And then we have our server block list, and we are referencing that particular server right there, and what action we need to take in relation to a IP address or a server address appearing on that list. So we're setting up a UTM policy. It's just called spam1, and in our security policy, this is how we activate that UTM. This is how we direct traffic into that process. Is we have a security policy from zone client to zone server. Policy external client inbound, and once we get to the commit function, we then got the application services parameter, and we're referencing UTM policy underneath that. Yeah, so we did exactly the same thing with our IDP. You may recall we had application services, and under that we had IDP, which meant that the traffic was then evaluated by our IDP. You can have both. You probably will have IDP. But then you can add in UTM policy spam1, which means that your traffic will then be evaluated by IDP and your UTM policy. So it's quite likely that you will already have IDP sitting under there, and you'll add your UTM policy in there as well. You can go into the JWeb interface and configure this through the graphical interface as well. So sometimes it can be easy to do that. Quickly, here we are. This is our setting up a whitelist here and a blacklist in there, and we're just adding addresses into those lists. So it can be fairly easy to do it like that. Got our genus defaults is up there, and our custom tag string is spam, so it appears on the list. We're going to tag it. We've chosen over here on the profile, we've chosen to tag it rather than block it. Okay. So we can verify it from the CLI, test security UTM anti-spam profile. You can have a test string in there. Here's an example of that test string. There's a particular IP address and return the spam action tag, email subject reason matches a local block list. And this is a test string which is Juniper.net. In this case, it is going to allow. So you can test an IP address, you can test on the domain name as well. Looking at our stats, show security, UTM, anti-spam statistics, and take a look at what's been tagged, what's been dropped, etc. And look at the status of that server. We're also going to our system log, which is the messages log, and we can do a search on anti-spam. Because any spam will be recorded in our system log, which is called messages file. You go and take a look in there, see what's going on. So let's look at a case study before we wrap up this topic. So we want to allow emails from John at xyz.com to reach the local users, and do not tag a spam tag other inbound emails from xyz.com as spam, and tag the subject line with the string spam. We're going to enable the SBL server to protect against other spam. Okay, so if we go to our whitelist, we're going to put in john@xyz.com, and in the blacklist, we're just putting spam@xyz.com. Special address to block unknown spammer host. So just the spam is like it's kind of like a wild card in there. Whitelists are evaluated first, then the blacklists. In our feature profile under anti-spam, we're referencing our blacklist, referencing a whitelist, and then we're going to put our SBL server in there, and we have our SBL default server, and the spam, the action there is spam action is tagged with subject, and we have the tag itself, which is asterisk 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 spam asterisk asterisk asterisk. So we are creating a UTM policy under anti-spam, and then we're referencing our policy. Policy name is policy 1, I think. Then we're referencing that policy under a security policy. And make sure we've got our name server set up. And we can go ahead and test it. We find that matches our blacklist. Okay, so we had a look at how anti-spam works, describe how UTM examines traffic for spam, and configured and verified and monitored anti-spam operation. Okay, the thing is, if you do go ahead and implement this, be prepared to have to put some organizations on your whitelist, because you most likely find that with people that you need to get emails from, organizations that you need to get emails from, that could easily appear on a block list. As I said, it's not that difficult to end up on a block list. Okay, so what are the global UTM configuration elements for anti-spam? Okay, so what we're doing, we're really setting up three things: a whitelist, a blacklist if you need them, and our server block list parameters. What is the match importance order to identify spam? So first of all, we're matching the whitelist, then the block list, and then our server block list. So actually our SBL server. Which commands can you use to verify that anti-spam is working at the time to cheat? Test security UTM anti-spam profile, and we put a test string in there, so to see whether that is blocked or allowed. We should know what we're expecting to happen. With that, we're expecting that one to block. And it does, that block. Okay. Alright, so that's anti-spam. Kind of had a look at that. Things to think about: your file server is going to be behind your, so your mail server is going to be behind your firewall for this to actually work, because it only examines the SMTP protocol. And be prepared to put certain organizations onto your whitelist if you go to implement this. And you have control over your blacklist as well, which is kind of nice. Alright guys, we are going to take a lunch break at this point. How are we going for time? We're going to take a lunch break at this point. And after lunch we'll come back and look at the other UTM features. So we'll look at the antivirus, look at the web filtering and the content filtering.